Let's start by talking about what an inequality is. What is an inequality? You did a little bit of this in grade 11? Yes, I think so. Yeah, but they wouldn't have been polynomial inequalities. It would have been probably just linear. But what's an inequality? They're similar to equations, except instead of the left side equaling the right side, there's some other symbol. So, and for us, those symbols are always going to be things like less than, greater than, less than or equal to, greater than or equal to. Okay, this is a good chance. Some people struggle with those symbols because you don't see them as much. And when we do domain range, they have a problem with that. Oh my goodness, like we can't afford to not understand those symbols and get those backwards. So really, really take today, we're going to do this over 2 days, and then we're doing other kinds of inequalities. So we're going to be spending some time with this. So really make sure you get that part right. Okay. But what does that mean? Solving an equation is when two sides are equal. So we're looking for the value or all the values that make the equation true, that make the left side equal to the right side. So similar, except let's take a look at that first one. When is the left side greater than or equal to the right side? Whatever the right side happens to be 0. Turns out that makes it a lot easier. So today is a simple, small step into this world. Okay, all the questions today are one of the sides is already 0, so that makes it a lot easier. But what does that mean? Well, it means. Well, what do you think? Like when you look at that, if I didn't teach you how to do this, what could you start with? What knowledge that you already have could you like tie this into and start thinking about, well, how could I, like what even if it's not going to get me the whole answer, what could I at least start with? Destiny.
You could figure out what values make it equal to 0.
Right, which values make it equal to 0? I mean, that's what we did yesterday, so that would make sense. And that part is easy. Can you give me an example? So at 1, it's equal to 0. So that's going to be part of our solution. And at -3. But the problem is the greater than part. Because when it's equal, it's only going to be equal to at certain points. But it's going to be greater than it in a whole bunch of areas. Right? Anybody have anything to add about that? John? Very nice. So any value of x that I plug in that gives me a negative will not work. Very nice. I like that. That's helpful. What else? There's something really important way of thinking about this sort of stuff that we've really started. I've encouraged you to do, and I think a lot of you, most of you, started really doing. How can we think about this? What knowledge that we already have can we use to help us figure out the rest of this problem? Okay, I'm going to draw something here. Don't draw this, just watch. Number line. So here is -3. Oh, it's frozen? Okay, that's fine. Here is -2. Here is +1. Those, do you agree those are the values where it's equal to 0? So, yes, yes, yes. What about between those two values? What happens there? If I'm right around 1, at 1 I'm equal to 0. Around 1, is it bigger than 0 or smaller than 0? What do we already know that can help us think about this and solve this problem? Jason?
Well, wouldn't it be whenever it's greater than 1, it would be bigger than 0?
Why?
Because it's a degree 3, which means it's kind of just going to go up in that direction forever.
What's Jason doing right now? That's like, I think was a technique, a skill. He did something that's really useful. That I've been talking about a lot. But let's like name it. Like, what did he do? Let's explicitly, what was that? Thought of the graph. This is an inequality, like an equation, right? It's not like a function. It's not y equals or f at x equals, the kind of thing that we graph. But if I thought of the graph, consider f at x equals x minus 1, x plus 2, x, x plus 3. Consider that graph. We know a lot about that graph. Could I sketch that graph? How about I'm going to try. What do I want here? Oh, I want to do this. I'm going to make this a little bit smaller. I'm going to turn my number line into a graph. So where's 0? Right about here. Okay. So my function has, those are all linear factors like order 1 x-intercept. So it's going to go something like this. Whoops. I didn't mean, that looks like the thing is right there, but that it's not, so I didn't mean to do that. So now, what can we say? Isn't that useful for this question? What can I do now?
So you can just look everywhere where it's above the x-axis, and that would be when it's greater than or equal to 0.
Very nice. So it's above the x-axis here, and it's above the x-axis starting here. And because we know a lot about polynomial functions, we know it's not going to turn back. We know it's going to keep going. We know what the end behavior is, right? See how that's important. We know that that graph's just going to keep going up that direction. Doesn't turn back this way, doesn't turn back down, doesn't do anything, just keeps going, okay? And same thing down here is never going to turn back up or do anything like that. Like, it's just going to keep going down. It'll always be below the x-axis down there. Okay, so we just use this. So when f at x is greater than or equal to 0, which is when it is above the x-axis, will be our solutions. So we have multiple solutions. There's different ways that you can write it. We're just going to write it with like set notation for now. So we're going to say -3 less than or equal to x less than or equal to -2, and when x is greater than or equal to 1. Does that make sense? It's pretty easy. But we're using the graph and our understanding of the graph to help us solve this. I want to point one more thing out before we go on to the next. That's basically all we're doing today. It's pretty straightforward. I want to point one thing out, though, before we move on. If I'm below the x-axis, which we are, to the left of -3, the first x-intercept occurs at -3. There's no other, like, it'll never be above, right? Like, past this direction, it'll always be below, right? Between these two, it'll always be above. Is that true? For this graph? Like, we can see it in the graph, but picture other kinds of graphs, okay? So between successive, and by that I mean like two x-intercepts that are side by side, there's no other x-intercept between them. If it's above the graph anywhere in here, it's above the graph everywhere in here, in other words. Does that make sense? If I'm below the graph here, in any one place, I'm going to be, between those two x-intercepts, I'm going to be below the x-axis everywhere between those x-intercepts. Does that make sense? It might seem weird why I'm saying that, but the reason is, graph, another thing I could do is I could check one value between each of those x-intercepts. So between -2 and +1 is the number 0. If I plug 0 into this, basically finding the y-intercept, it's a good thing to do anyway. What do I get? That's easy math, right? So -1 times 2 times 3 is -6. So it's negative at 0 means without graphing, I know where the graph is between those x-intercepts. This one's a bit trickier. I'd have to use -2.5 to test this, I suppose. Does that make sense? Everybody following me okay? But if I plug -2.5, this would be negative, this would be negative, and this would be positive. I can see that by looking at just those brackets, right? I'm not even doing the math. I'm just like -2.5 is bigger than that, so it's going to be negative. -2.5 is smaller than that, so it's going to be positive. So I have two negatives and a positive, which is positive. Whatever the value works out to, it will be positive. So I know the graph will be above the x-axis between those x-intercepts. Okay, we're going to use the graph to solve, so we don't have to do that test, but we call that like an interval test, is actually an important technique, and it's something that comes up later in this course and in calculus. It's a neat little trick. So it's something that's good to think about. It's another way that we could, without graphing, if for some reason we didn't want to graph or weren't able to graph or weren't allowed to graph, that's another way you could do it. If I was checking the interval past 1, I would use some big number to make the math easy. So 10 minus 1, 10 plus 2, 10 plus 3, those are all positive. So my graph's positive. -10 minus 1, -10 plus 2, -10 plus 3 are all negative. 3 negatives makes a negative. So my graph is negative as I go down further. Does that make sense? Anyway, okay.